Have you ever wondered how scientists can manipulate molecules using light? Well, they just made it possible. It's a groundbreaking achievement that has seen the merging of photochemical reactions and molecular self-assembly. Now that might sound like a mouthful, but it's actually quite fascinating. Imagine the power of light, that same warm glow from the sun, being wielded to create molecular fits that laugh in the face of thermodynamic equilibrium. It's almost like a magic trick, but it's real tangible science. Our understanding of thermodynamics tells us that systems seek stability. They aim for equilibrium. But here we are, scientists manipulating molecules with light, creating systems that defy this fundamental principle. They're not just bending the rules, they're rewriting them. This innovative approach might just be the door to a new revolution in technology and medicine. But how exactly does this process work? You may ask. Well, let's break it down in simpler terms. This groundbreaking phenomenon combines two fascinating concepts: photochemical reactions and molecular self-assembly. Photochemical reactions are essentially reactions that are triggered by light. Imagine you're a molecule, just hanging out, doing your thing. Suddenly, a beam of light strikes you. This energy spurs you into action, causing you to react with other molecules nearby, creating something entirely new. This, in essence, is a photochemical reaction. Now let's move on to molecular self-assembly. Picture a group of children playing with building blocks. They instinctively know how to fit the pieces together to create a structure. Similarly, molecular self-assembly is when molecules spontaneously arrange themselves into organized structures. They don't need a blueprint or a guide. Given the right conditions, they just naturally come together in a specific orderly manner. So what happens when these two processes, photochemical reactions and molecular self-assembly, combine? That's where the magic happens. Scientists have discovered that by using light, they can manipulate the orientation of molecules during the self-assembly process. Instead of letting the molecules arrange themselves haphazardly, they can control the process, guiding the molecules to form specific structures. This is akin to a conductor leading an orchestra, ensuring each instrument plays at the right time to create a harmonious symphony. Except in this case, the conductor is light, and the orchestra members are molecules. This innovative approach allows scientists to create dynamic systems that defy the standard rules of thermodynamics. It's like they've discovered a new cheat code in the game of science, enabling them to achieve feats that seemed impossible before. This is not just about bending the rules of science, but it's about creating a new set of rules altogether. Now you might be asking, why is this so important? Well, let's break it down. This scientific breakthrough is like discovering a new law of nature. It means we can use sunlight, a resource that's abundant and free, to manipulate molecules in ways we couldn't before. Imagine creating new materials with properties that defy our current understanding. This could revolutionize industries across the board, from building and manufacturing to technology and design. Now think about medicines. The ability to control molecular orientation could lead to the development of drugs that are more effective and safer. This could mean new treatments for diseases that are currently incurable and better health outcomes for everyone. And then there's the potential for dynamic systems that mimic non-equilibrium processes in living organisms. This could lead to advancements in areas like artificial intelligence and robotics, as we learn to create systems that can adapt and evolve just like living creatures. In essence, we're talking about a discovery that could redefine our relationship with the natural world and the way we harness its resources. This discovery has the potential to change our understanding and interaction with the world around us. So, what have we learned today? We've journeyed through the intriguing world of light and molecules and how they've been made to dance an intricate dance. We've seen how, with the power of light and a bit of scientific ingenuity, molecules can be manipulated in ways that were previously thought impossible. This dance is not one of random chaos, but of precise choreography, brought about by the combination of photochemical reactions and molecular self-assembly. Scientists have used this pioneering approach to create molecular fits that defy thermodynamic equilibrium using light. And the implications of this achievement? They are vast and far-reaching. Imagine a future where sunlight could be harnessed to develop materials, drugs, and dynamic systems, mimicking non-equilibrium processes in living organisms. We're talking about potentially revolutionizing technology and medicine and opening up a whole new world of possibilities. Science continues to amaze us, doesn't it? And this is just the beginning of a new era of possibilities.